Okay, good morning again. So can somebody please tell me with I'm sorry, I'm lost because the two different sections have different uh, we were not able to end at the same time as the other section. I mean, same lesson. So anyway, let's just quickly review what we have discussed so far. We said that, just a quick review, okay? The ARIMA process requires that you can only model a time series if they are stationary. Now, the reason for this is it's easier to model a stationary data series. If the data has trend, or whether it has seasonality and non-constant variance, then the ARIMA approach would not be the proper way to do it. There are other forecasting approaches, time series approach, that is better suited to deal with that data. So if a data has trend, then it has to be transformed. Okay, we all know that. If the data has a non-constant variance, then there has to be a transformation done in order for us to use the ARIMA model. Now, the advantage of an ARIMA model, it's simple. Okay, it's more robust, but there has to be transformation done before we can use an ARIMA process. And we have learned about the formula, okay, how an ARIMA model looks like. Hold on a minute, class. Okay, sorry for the disturbance. All right, so just a quick review. We looked at the okay. You have this, no? The univariate because you're only dealing with one time series. If you're modeling more than one, it will be a multivariate time series, and there's another way. There are other models to do that. So for our purposes now, we're dealing with univariate, and we learned about the AR1 process and A1 process. Oh, sorry. Yeah. Okay. AR1 process, MA1 process. We learned about that. Okay, so I'll not go there. So an ARP process, class, model short time series as a function of P lags of the values of itself. No? So we have phi1 up to phi sub P minus, this is phi sub P minus 1, and then phi sub P. Okay, this is an R of order P. And then the quote-unquote independent variable is X, your time series, lagged at P, T minus P, plus a certain error term. Okay? So on the other hand, for an MA model, you're making use of the past error terms. And we oftentimes use the theta function. Okay, by the way, have a little review of the backshift operator, because this one can be written as, recall, class? How can you rewrite this? Theta 1 times L, right? Or theta 1 times B raised to the 1 power. This is theta 2 times B squared, right? B squared, okay, B squared of epsilon sub T. Okay, B squared of epsilon sub T means the log of 2. Log 2 of your epsilon. Okay, so we learned about the different processes, like combination of AR 2-1, that's an ARMA 2-1, where we have two lags of the time series itself and one lag of your error term. Okay, Now, we said that we can only model your time series if it's stationary. So quick review class, if your data, if your time series displays a trend, so that has to be treated, that has to be transformed, because we cannot use ARIMA model if your data has trend, if your time series has trend. So it has to be detrended, and oftentimes just by differencing, it will already address the trend. It will convert it into a stationary data series. Okay, if it displays non-constancy invariance, there's a fanning out or fanning in, then to address that, we can get the log of your time series. Okay, because the log function will scale your time series, and then it could treat the non-constancy invariance. So when we have to do both, then we first get the log and then get the difference. We need to get the log first and then get the difference, because doing otherwise will mean we'll be generating uh, uh, either error terms or not a number. Okay, so we first get the log and then get the difference. I hope I don't sound like a broken record, because this is something that sometimes students tend to make a mistake of. So that's why I keep on harping over this. Okay. Now, if we get the log and then get the difference, what's that equivalent to? Anyone, please? Getting the log and then the difference, or the diff log, difference of the log of the time series, is equivalent to getting your
Stock returns po.
yes, the returns, the log returns. Okay, it's not just the returns but the log returns. Okay, and if that's really what you're modeling, then you really have to get the difference of the log, the difference of the log of your prices, of your stock prices. Okay. Okay, so I think we covered because it's almost the half the term, no? Parang ARIMA tayo, and we have to move on. Okay. So just to summarize quickly the steps, we have to convert the data into a stationary data. Okay. So, and of course, once we have done that, there are several statistical tests in order to check whether our data is stationary. Foremost among them is the augmented Dickey-Fuller test and the KPSS test. Okay, we learned about that. And then we can also, once we have determined that the data is indeed stationary, then before, what we did was to determine how do we now determine if it's an AR process, an MA process? It's by getting the PACF and the ACF, autocorrelation function and the partial autocorrelation function. To determine if it's AR process, we focus on the PACF. Okay? So if the PACF shows, ano yung class? What's the characteristic, or how does the PACF look like if it's an AR process?
Cut off, sir.
Cut off, correct. Cut off sa ACF, PACF. Tapos, how about sa PACF?
Tail off, sir.
It's a tail off, no? So, yun ang makikita natin. Tapos vice versa naman, no? Kung MA process, we look at the ACF, if it's a cut off there and the tail off at the PACF, then there's a strong chance that it will be an MA process. So paano naman class kung ARMA? Paano kaya kung ARMA class?
Either both cut off or tail off, sir.
Okay, pareho, no? Parehong either, sometimes you'll see pareho silang nagte-tail off, or sometimes pareho silang nagka-cut off. No? So that's indicative that it could be an ARMA process. Okay, so just take note, class, when you're modeling, be sure to understand, be sure to know what you're modeling. Kasi pwede ang minomodel natin yung original time series, kunyari original time series is already stationary. But for stock prices, that's more of an impossibility kasi very very sensitive ang prices sa movement sa market or sa signals coming from the macroeconomic environment or from the whatever market environment there is. So hindi ka makakita, class, no? Unless na parang yung stock na yan is let's say insensitive to any movement in the market. And siguro very rare yung klase ng stock na yan na parang whatever happens to the market, hindi siya gumagalaw, no? Hindi siya tumataas, hindi siya bumababa. Chances are, especially if that stock is traded in the market, may galaw yan, either going up or going down. Okay? So, I haven't seen a stock. Maybe may mga ganun siguro, but that could be very rare. Na kunyari, since it's opening, kunyari 1990 nagsimula siya, tapos hanggang 2023 plinat natin yung time series plot niya. Tapos walang movement na pataas, no uptrend, no downtrend. Ganun lang siya, no? Stationary lang siya. Constant mean lang siya. So siguro yung mga ganong klaseng stocks, yung halos hindi trade, tapos hindi siya pinapatronize, walang masyadong bumibili or gumagalaw, nagtatrade sa kanya. Pag ganun kasi, class, pwede. Pag walang nagtatrade sa stocks na yun, hindi gagalaw yung di ba, yung prices niya. Kasi yung prices naman gumagalaw yan because of well, strictly speaking, it follows the supply and demand law, di ba? Tataas yan kung kunyari very bullish yung market, so many people would want to invest in that stock and earn from the uptick of that stock. So tataas yung demand, tataas yung price na yan. And then the reverse is true. Kunyari may downtrend, may negative news about the stock. Kunyari, let's say the industry has experienced a hit, no? Nagkaroon ng scandal dun sa industry na yun. Kunyari yung market na yan, yung industry na yan, yung product nila is nagkaroon ng poisonous. Example, ganyan lang. Na yung poisonous yung product, yung ginagamit dun sa and the industry took a hit. Siyempre, ang tendency niyan talagang gagalaw siya pababa. Unless, again, that stock is isolated, okay, it's impervious to any any signals coming from the market, which is very rare, as I said. Okay, so we said that the steps are, bakit natin kailangan ACF at saka PACF natin? In order to determine kung ano siya. In order to determine kung anong AR or MA process yung gagamitin natin para sa modeling nila. But nowadays, class, as we said, in the advent of statistical softwares, which will do the modeling for us, actually, hindi na natin kailangan yung ACF at saka PACF. Well, it still has a purpose, no? Kung later on, once we have a model, tapos prinat natin yung residuals ng model, tapos nakita natin na white noise na yung ACF at saka PACF na residuals, which indicates that okay na yung model natin, no? Which means that the ARIMA model that we generated was able to capture the movement of the stock. Kasi, kunyari nag-model tayo ng ARIMA, tapos kinuha natin yung residuals, tapos lumalabas may mga significant spikes pa, then that means class na ibig sabihin nun na yung heteroscedastic yun. Yung residuals natin are heteroscedastic, and it means that perhaps yung model natin hindi pa sufficient. Maybe kailangan, siguro there should be a more transformation, or we should be using another model. Okay? So the ACF and the PACF will have its purpose. Not necessarily for just looking at the model that we can use, AR or MA, but also for diagnostic tests. Okay, am I making sense, class? Clear so far tayo? Paki-chat please kung okay tayo. Kung okay so far. Okay. Dalawa lang, okay. Okay, thank you. Apat. Okay, salamat class, no? Salamat sa feedback. Okay, so let's finish this class. Ito example natin. Let me check if my model is still here. Dito ba yung bud ko, no? Okay, so very quickly, we were using the okay. Ito class, no? Ito yung ginamit natin, yung difference ng log bud. Okay, because we were assuming that we are interested in the returns, log returns of the bud series. Okay, perhaps if we were just interested in modeling the price, baka sufficient na yung just getting the difference of the bud. So take note class, depende sa objective natin, ha. If we're modeling the price of the bud and just by getting the difference, stationary na siya, then we're okay. We don't have to get the log of the bud. Kasi sabi natin, the simpler the transformation, the better it is to model that. But in this case, we're interested in modeling the returns. So let me see. Let me just check. Asa yung DL-BUD natin? Yeah, dito pa, no? If I click this. Okay. Present pa ba class yung DL-BUD nyo? Ay, what happened? Ala. 3389. Pero why doesn't it show? Okay. Tago lang. All right. 3399, no? Okay, class, are we on the same page? Do you still have the DL-BUD there with you? If not, class, I'll give you a few seconds. Just make sure that the object DL-BUD is accessible, is loaded. Okay, wait. Sorry. Mali naka-cancel ko. Okay. And if we plot this, okay, so yung DL-BUD ko dito, na omit ko na yung yung missing value because the first observation will be NA. Kasi nga, di ba, pag kinukuha natin yung difference ng log, magkakaroon ng NA dun sa first one. If I plot this, just to make sure, oops, unable to. Okay. Sandali, nagkaka-problem ako dito sa ano. Let me check again. DL-BUD. Yeah, tanggal na yung ano, no? Natanggal na yung ano, yung missing value. Kaso wait. Bakit naging ano to? Bakit naging ganito yung data ko? Okay, ito. Yan. Okay. So, July 2, no? Okay, so this is okay. Are you following class? Paki-check yung data nyo, ha? Kasi very quickly, babalikan natin to. So, if I plot this, plot DL-BUD, yan, okay? Here. So, is the data stationary class, the difference log BUD stationary? Answer please, class. Is our difference, difference BUD yan. So actually, yung difference BUD, no? Itong difference BUD, stationary na siya. Although may makikita tayong mga volatilities, no? Mga volatility clustering tayo. But if we're just modeling the price, then we can check statistically based on the ADF test kung stationary yung data series natin. If it's stationary, then okay na to. If we're just modeling the bud prices. Okay, so where am I? Okay, dito bakit ayaw mag-plot ni ano? Plot DL bud. Ba't ayaw mag-plot? Okay. Kaya pa ako nagkaka-problem sa ano. Where is that? Nagpa-plot ba sa inyo, class? One more. D-bud yan. Ito, log. Okay, come on, come on. We need to move on really. For some reason, class, ayaw mag plot nitong ano ko, nitong DL bud. Okay, I'll just skip that, no? But I'm definite that it's already stationary. So here, as I said, we check statistical test to. We check if the data under consideration is already stationary. Ginagamit ko kasi yung post-it eh. Kaya ito yung kasi yung ginagamit natin during class. So nagkaka-problem ako, parang ang tagal ng ano, ang bagal ng connection. Nagra-run pa siya. It's taking long. Control A. Okay, sandali class ha. Let me just run this in a regular R. Let's see. So hopefully. Okay, I transferred it to my R studio file. Kasi dito sa R post-it, oh, it's taking some time. Ang tagal eh. Okay, anyway, so I'll just transfer here to my R file, R studio file. Okay, so let me see. Now I have to run. Problema nito, ira-run ko muna. Okay, just quickly, class. I'll just choose some. So ito, no? I'll just choose this. Okay. Tapos, so bud. And then, I'll get the adjusted bud ito. Just to get the adjusted price. Run ko to pareho. And then, what else? Okay. Bud 1. Ang ginagamit dito, bud 1. No? Bud 1. So what am I doing, class? I'm just rerunning this from POSIT to my R Studio. Kasi ang bagal dun sa ano. I'm having difficulty running it through the net. It's taking some time. So better use my machine. So, I have to run this. No, I have to get the log. No? So log first. Okay, here. Get the log. So that will be lbud get the log of bud, and after that get the difference. This one, difference of log bud. Like, do I now have it? Here. Okay, I have it now, and then I'll plot this. Yan. Okay, so you can now see that the difference of log bud is stationary. May mga volatility clustering tayo dito, no? Okay, later on when we do ARIMA, in a while, we will have to check if okay yung model natin, kasi if it's not, ibig sabihin yung residuals natin may mga hindi siya white noise, then it might indicate that the presence of significant autocorrelation might mean that the ARIMA model is not sufficient. Pag may mga gantong presence ng volatility clustering class, it requires that we use the GARCH model. Okay, so anyway, sige. So now, okay, sana tayo? Okay, ADF test. Okay, let's see. Ay, wait. Hindi ko pa pala tinanggal ng sa DLBUD. I haven't removed ito, no? I have to omit. Okay? Omit the first entry there kasi NA siya. Tapos, i-test ko. There. Alright. Ang null hypothesis natin dito, class, it has a unit root, aka not stationary siya. Since the p-value is 0.01, less than 0.05, then we reject the null hypothesis that there is a unit root, which means that walang unit root, ibig sabihin ng class, stationary siya. Okay? Then we used before the KPSS test. I won't go there anymore. We have done that. Okay, so I'm going to the model now, class. Okay, ano yung ARIMA natin dito? Okay, punta na tayo doon, class. No? Although what we did also was to do the PACF and the ACF test, the plot, di ba? So just quickly, so there are several ways, class, to do the ACF and the PACF. So if I do this, ito na lang, no? Makikita natin dito na ACF, no? Okay, so let me run this. Okay. So we already did this before. Sabi natin, based on the ACF, okay, may mga significant spikes, di ba? So just by looking at the PACF and also here the ACF, it's quite difficult to determine kung anong model yan. Looks like pwedeng ARMA model to, but we cannot be sure about that. That's why we have to let R do the modeling using the auto.arima. So this one we did, diba? And let me just run this trace is equal to true, which will trace the different models. I-run natin to. All right, so here, and it tells us that the best model is this one, diba? It's an MA4 model, yan, 004 with zero mean. It has the least, dito siya, no? 18086 negative. Among these models, this is the lowest AIC. No? Okay, and then refit niya, it refitted it kasi yung unang pag-model niya dito, approximated lang yan. No? But this time, after finding this, then it refitted it without approximation this time, and we still have the same model 004 with zero mean. This is the AIC. And I recall last time we already learned how to create this model, diba? Okay, what's the best model? We already defined that. Okay, and then let's go now to hindi ito. So nag-simulate din tayo ng ano, no? Okay, punta na tayo class dito sa ano, after this. Okay, let's do some diagnostics. Okay, notice I said ARMA or MA04 for the LBUD. I didn't put the differencing because we didn't anymore difference the LBUD. It would have been different class if, okay, sandali, let me just, as an afterthought class. Ano yung bad one na data natin? As in bad one na data. Ito, no? Bad one data. This is your adjusted, di ba? Adjusted price to. Okay. Now, what if we let R do the modeling for us? Okay, dito ako maglalagay. No? Dito na lang muna. No? Okay. So let's see. Kasi what we did was we get the log, di ba? We got the log and then we got the difference. I just want to show this to you. Let me call this model, I'll just call it model 100. And then here, we're going to use the bad one. Okay. Now, this is a scenario where we're letting our model the original time series for us. Let's see what will happen if we do this. Run natin to. Okay, so ang lumalabas dito class na if it's the original data series, it should be yan lang class, oh. ARIMA 1, just difference it. Difference lang siya. So just difference it, and then the best model is ito lang, ARIMA 010 lang. So just difference the model. Ito lang, 10.321. It has the lowest AIC. Okay, ibig sabihin class, yung difference na model will already be sufficient. Hindi na tayo makakapag-extract ng ano. So, you notice the difference, no? Yung bad lang yung ginamit natin. Kasi ano ba yung itsura ng bad class? Plot bad one. Okay, so it's not at all stationary, di ba? Tapos nung pina-model natin siya kay R, ang lumalabas lang na ano na it's just an ARIMA 010. So i-difference lang tapos yun na yung model, no? Just get the average of that. Yun na yung best model if it's just bad one. However, compare natin to what if i-plot natin, meron tayong isa pang, ano, di ba, yung log bad 1. Ay, okay. Hindi ko rin siya. I think it's, dapat nasa inyo yan, ano? We did that eh. Ito. LBAD lang pala siya. No? So, LBAD. So, let me run that. Am I going too fast, class? Sorry, kasi hinahabol ko yung dapat ma-diagnostics natin eh. LBAD. Okay, logbad. I-plot ko siya. Okay. We can see that getting the log did not treat the non-stationarity. Kasi pag mag-ADF test tayo, no, ADF.test nitong logbad. If we check kung stationary siya, okay. Hindi ko pa na-run yung forecast. Ayaw mag-run ng ano. Run ko muna yung mga libraries. Okay, class, while it's running, ano ginagawa ko? I'm just comparing, no? Kasi kanina kinuha natin difference ng logbad, no? What if we just modeled bad 1 right away? Ang lumalabas nga dito pag bad 1, just get the difference, no? Yun na yung model natin. Just get the difference and then the average of that will be the model itself. Ibig sabihin walang ARIMA component, no? Pag bad 1 lang. Which is the adjusted price. Now, yung pangalawa naman, ang ginamit ko ngayon yung log ng bad. So where's that? Okay, so this time, yan. Okay, so ano sinasabi dito, class? What's the null hypothesis here sa ADF test na may unit root test aka non-stationary siya, di ba? Right? So ibig sabihin, class, that getting the log of the time series did not treat the non-stationarities. Non-stationary pa rin siya, no? Kasi we failed to reject the null hypothesis that the data is not stationary. May unit root eh. So not stationary yung data. Okay. So pag ganyan, class, what will happen if we ipa-auto.arima natin to? Just like this one. Control C. So yung logbad, yung logbad. Okay, model 101. Okay, this time, class, I'm asking R to generate an ARIMA model if it's the logbad. No? So yung movement ng logbad is just the same as yung movement ng bad. Medyo nabawasan lang yung variance, no? Yung non-constancy in variance. So if I run this, okay. What do you notice, class? I hope. Oh, Adi, Adi, yung question mo, paki-share sa lahat. Can you share the question, Adi, to everyone? Yes. Will the null hypothesis? Yes. Pag ADF test, ha? Okay. Siyempre, iba-iba yan. Like yung KPSS test. Okay. So just to make sure that everybody understands, yung ADF test, class, ang null hypothesis yan, balikan natin dito, ha? Okay. Ito, no? Ito class. Ang ADF test natin, ang null hypothesis niyan is that there is a unit root, aka not stationary. On the other hand, si KPSS test, baliktad, no? Si KPSS test, the time series is stationary. Okay, so it depends, class, on what test you're using. Pag ADF, not stationary yung null hypothesis. Pag KPSS test, stationary. Okay? So magkaiba opposite sila, no? All right. So dito class, what do you notice about the model? Ano sabi niya? I'm not sure if I mentioned this to you before, but I think I mentioned this to you before. But I just wanted to show you class, anong difference ng getting the model for the difference log bud at saka ng log bud. Anyone please? When we modeled log bud, ito, no? Yung ngayon, di ba? Ito, class. Anong suggested model? Yan, di ba? ARIMA 014. Okay. What's your comment about this class? MA component, okay. Yeah, MA4 nga, ano? Pero how does this compare with the, let's say with the, yung minodel natin na, ano, na
Recording in-
difference log bud? Yung minodel natin na difference log bud. For MA logs, okay. Kindly share your answer to everyone, please, no? What about that, Glenn? Yes, for MA logs, di ba? Order 4, no? Ang MA natin has order is equal to 4. So anong difference niya, class? This is the result of modeling log bud, di ba? How does that compare with modeling difference log bud? Anyone, please? Compare nyo to, class. In terms of coefficients, what's different? Minomodel natin yung log bud versus difference log bud. Come on, class. That's easy to answer.
Sir, can I try?
Yes, sure. Go ahead.
According sa dito po sa ARCO, sir, ARIMA 004 po siya.
Yes, okay.
Yung integrated part ng model is 0 po sa DL bud.
Yes. Okay. Tapos,
Sir, yun lang po yung answer ko.
how about the coefficients? Michael. Anong
Wait.
difference ng coefficients ng model for the DL bud at saka L bud? Compare mo yung coefficients ng MA, MA1, MA2, MA3, and MA4.
MA2 and MA3, they're the same po. Whereas yung MA1, its difference is 0.0001.
So,
Tsaka
maliit
yung
lang,
sa
di ba?
MA4,
Maliit lang siya, no?
0.0001.
Practically the same, no?
Yes, sir.
Yes, practically. Now, why are they the same? Class, why are they the same? Obviously, class, because you're modeling the same series, di ba? Kanina, yung minodel natin, difference log bud. ito class, logbud. Pero take a look at this. Ang sabi niya, si logbud class, hindi pa stationary yan, di ba? Kaya nga, ang sabi ni R, i-difference muna yan. Kaya nga may 1 dito. So pag dinifference natin si logbud, what will that data become, class? Can you tell me, class? Exactly. Thank you, Glenn. Exactly, class. Difference na rin siya, di ba? So pag dinifference natin si logbud, how does that now compare with the difference logbud, yung unang minodel natin? They're the same, di ba? Kaya nga 0, 4 din yung MA component, yung order ng MA. Kaya nga pareho din yung coefficients. That's what I wanted to point out, class. Kanina, when we modeled difference ng logbud, we were modeling a stationary time series. Diba? Difference logbud, as I showed you, class, is already stationary. Therefore, there was no need here, class. Ito. Difference ng logbud, di ba plinat ko yan, di ba? I plotted that just to make sure that we know where we're coming from. And when we plotted difference logbud, it was no longer, it was stationary. Okay? You can test, class. Tingnan natin, ha? Mag-test tayo dito. Dito ko ilalagay. Okay? Dito muna. Bago tayo mag-auto.arima. Tinas ko na ba dito yan? O, ito, class. So, di ba tinas? Hindi. Yung plot pala, no? Yung plot yan, eh. Dito, so let me put here, class. Mag-ADF test tayo dito, no? ADF, just to satisfy our ADF.test, DLBUD. Okay, and we can see here, class, that yan, 0.01, di ba? P-value is less than 0.05, therefore we reject the null hypothesis that there is a unit root or the data is not stationary. Tandaan nyo, class, ADF, ha? How about KPSS test? KPSS dot test. Oh, ito yung tinatanong kanina ni Michael. DLBUD. Okay, ito naman, class, ang null hypothesis ito opposite. No, na no unit root to or stationary data. Tingnan natin what happens. Look, 0.0844. So ano to, class? We fail to reject the null hypothesis. This is not less than 0.05. We fail to reject the null hypothesis that the data, that the time series is stationary in time series. So, nung minodel na natin siya, class, ano nangyari? Tingnan natin yung final model natin. It's ARIMA 004. So, ibig sabihin nito, class, hindi na nag-difference. Bakit hindi na nag-difference? Kasi stationary na siya. Diba? On the other hand, ito naman, class, yung logbud, the logbud data, class. Okay. Si logbud data, based on, tinest natin yan, di ba? Based on ADF test, lumalabas na not stationary siya. Okay? So, nung pinag-auto.arima natin yung logbud, ang sinabi ni R, okay, there has to be a differencing. Yun. 014. Okay? 014. So, that means na i-difference mo na yan. Okay? Bakit kailangan i-difference? Kasi hindi stationary yung data natin, yung logbud. So, expected mo na magkakaroon ng 1 dyan. Okay? 014. Okay? As I said, nung nag-difference siya ng isa, it has already become difference logbud. So, nung minodel yung difference logbud, you're getting now 004. Diba? So, pareho talaga yun. Expected natin na it should be the same. Okay? Ang difference lang kasi nito, ito, yung logbud, i-difference mo muna siya. Pag dinifference mo si logbud, magiging difference logbud na yan. Pareho na yan dun sa kanina, di ba? So expectedly, the model will be the same. Okay? Pause muna ako, class. I hope I'm clear about this. Are we clear, class? Paki-chat naman, please, kung clear. Okay? About the others, please. Okay. Alright, hindi ko nalagay dito yung ano ah. Okay, so let's now go class to magte-test na tayo ng model natin, no? Ite-test na natin yung ano natin, yung ARIMA 004 for DLBAD or ARIMA 014 for LOGBAD. Okay. So okay, balik ako dito, class. Simulation natin to eh. Ito na tayo. 3. Okay, mag-diagnostics na tayo, class. Kasi we don't just stop at the model. We have to ang gagamitin natin yung yung DLBAD kanina. So, sinulat ko na dito para mas mabilis tayo. Okay. Let me get it here and then let me just okay. Dito na tayo. So we're now going to okay. Let's get the residuals, class, no? So di ba yung model natin, what's our model? Where is that? This one, model 1 natin, di ba? So gamitin natin, class, yung model 1 natin. Okay. So Control Alt I. Kunin muna natin, class, yung yung laman ng mod 1 natin. Mod 1 yun, di ba? Okay, bakit ano? Hindi ba? Ayun siya. Naran ko na ba yung mod 1? Ay, wala pa akong mod 1. Sorry. Pero naran ko na, di ba? Ito. Right? So mod 1. So this is mod 1. So take note, it's a list, di ba? It's a list of 18. Okay, naghalo-halo. Pasensya na, class, medyo naghalo na tong mga notes natin dati dito. I-X ko na muna to. Okay. Here, names. Yan, naroon na. Hindi lumalabas. Bakit wala? Okay. Ay, sorry. Ay. Mali yung function ko, class. Sorry. Names mod 1. Yan. So these are the elements of mod 1. Yung model natin, yung auto.arima model natin, ito yung laman niya. If you want, for example, to get coefficients, mod 1, and then $, diba? Coef, no? It will print to us the coefficients. No? If we want to get yung first 6 lang, head ng mod 1 residuals, yan, it will generate the first 6 elements of our residuals. Okay, so may residuals tayo, no? Okay, so ang diagnostic, class, titingnan natin yung residuals natin. Control Alt I. So let's create this object resid. So we're creating an object which is the residuals of model 1. Inspectionin natin siya. Here you go, class. Okay, we're creating this object resid and it's coming from your model 1 residuals. There. Okay, let's plot Plot natin si receipt. Tingnan natin kung ano bang itsura nito. Plot receipt. There. So, mukhang stationary naman siya, di ba? Di ba? Ito yung residuals na model natin, no? Okay? So we can check natin kung statistically, okay, Control Alt I. Pwede natin i-check kung stationary siya. ADF.test ni receipt. Okay, so here it tells us that the residuals is stationary. Okay, now what's important now is to have what we call a portmanteau test. Okay, a portmanteau test is a test where parang ano siya, parang a test where very well specified yung yung null hypothesis natin. So there are different types of portmanteau test for time series for ARIMA. Andyan si Leung box test. Andyan si box test itself then. Meron si Q test. Okay. So let's take a look at these three. Ang tinetest nito class is that if may autocorrelation yung mga residuals natin. Okay? Or if the residuals are heteroskedastic. Okay. Okay, para mas mabilis tayo. Okay. I'll just as portmanteau test ko. Okay. It's here. Iaano ko na lang para mas mabilis tayo. Yan. Here class, no? Ito. Okay. Let me share with you the code. And then, although no need class to, chat ko class ha. So these are your portmanteau test. Okay. Paki-copy sa ano nyo, sa copy ko na rin para ano. Nasa ano ko. Here. Okay. So what are we saying here? Yung portmanteau test natin, it's used to assess kung adequate yung ARIMA model natin by checking the presence of autocorrelation in the residuals. Kasi pag autocorrelated pa yung mga residuals, ibig sabihin nun, hindi natin na-capture yun sa model natin. Diba? Kasi kaya nga tayo nag-ARIMA para ma-capture natin yung autocorrelation. Kaya nga tayo nag-ACF at saka PACF para makita natin yung autocorrelation among yung data natin, no? Yung time series natin. So, yun ang kinakapture ng ARIMA, di ba? Kaya nga yung sa AR, yung y sub t is equal to a function of y sub t minus 1. Yung correlation niya with the past value of itself. Yung MA naman, autocorrelation ng error terms, no? So, if the residuals still display that type of behavior, may autocorrelation pa rin, then ibig sabihin ng class, meron tayong hindi nakaka-capture dun sa yung ARIMA natin hindi sufficient kasi hindi niya nakaka-capture yung autocorrelation. So sige, I'll just copy this class para mas mabilis tayo. Hindi ko yata na-copy. Okay. So sige, i-ano ko to, no? Control C, tas baguhin na lang natin kasi this is meant to be another Control V. Tapos i-copy ko sa chat. Kindly copy this. So we're running out of time. Okay. So babaguhin natin to class, no? Ito, may model na tayo, may model 1 na tayo. Baguhin natin to class. So let's start with the Leung box test, no? So if you take a look at the function, box test lang din yan, no? Box.test and then residuals nino class. Okay? Residuals ni mod 1 natin. Or we can just type resid, no? Kasi si resid na object. Okay, so let me show it to you first. So i-run natin to class. Tapos i-print natin Control C. Print natin. Okay. What do we have here? Okay, I'm going to give you class the okay, ano yung null hypothesis natin, class, di ba? Di ba binigay ko sa inyo? And this is the null hypothesis. No significant autocorrelation at any lag. Okay? No significant autocorrelation at any lag. Okay, what do we have here, class? P-value is 0.04. Therefore, do we reject or fail to reject the null hypothesis? Class. Reject or fail to reject the null hypothesis. Yung box.test, class, it comes from stats package. No? You actually don't need to do this library kasi it comes preloaded already with R. No? So kahit natin hindi i-run to, magra-run tong box.test na to. Yes, reject the null hypothesis. And the null hypothesis is that no significant autocorrelation. So that means, class, yung model natin, yung ARIMA 004 natin, may significant correlation still dun sa residuals natin. Okay? So, is that good or bad? Well, hindi siya maganda kasi ibig sabihin, hindi nakaka-capture natin yung ng model natin yung autocorrelation dun sa mga residuals. Okay, let me once again, okay. Ito, class, pareho lang to, no? Yung Portman 2 test, it's a family of tests. Pare-pareho lang naman sila, no? Okay, oops. So box peers naman tayo. I'm going to share this chat ko. Ibabago lang siya, class, ha? Okay. All right, then let's just copy this. Copy natin to, class, Control C. And then Control V. Babaguhin lang natin dito. Tanggalin natin yung. Okay. So box test lang to. Okay. And then if you take a look, class, ano yung difference niya? Tingnan nyo to. No? Yung type is equal to box peers lang. Share ko na lang sa inyo to para mabilis. Control C. Control V. Okay? So yung isa yung, di ba? Yung box, ito naman box peers. Okay, so let's copy this here. Control V. Okay? All right. Same din yung ano, yung konti lang difference ito actually, class, sa pag-compute lang. So, let's test this, yung box peers, and then this generates, okay, halos similar din, di ba? So, 0.04266, dito sa yung box, 4124, 0.04124. So, same conclusion, class, that yung residuals natin, may mga autocorrelation siya. So, hindi pa pwede yun, di ba? Pag ganun, class, sabi natin, we have to refine the model kasi may nakikita pang autocorrelation. Although stationary siya, di ba? Tapos, let me just, ito pa, may Q-test pa. Again, i-ano ko to sa inyo. Copy-paste lang natin. Okay, Control C. Pareho din to, class. So, tatlong test yung tinignan natin. Si yung box, si box peers, at saka si Q-test. But they just give us the same, no? No significant autocorrelation, okay, at any lag. Hindi ko pa na-share sa inyo. Okay, so dito naman, pwede natin gawing, class, na instead of the residuals of the mod 1, pwede natin gawin yung resid. Diba? So because this is our object, no? And then, ang difference lang, type is equal to Q. Okay, take note, dito ang ginamit natin yung residuals. So this is a function. Residuals ni mod 1. Okay? Or, we can use here either mod 1 dollar residuals or resid 1 mismo, no? Okay, I hope that's clear, class. If we run this, oh wait, sorry. Sorry mali yata yung function na ginamit ko. Pareho lang, no? Ba't ayaw niya? Sige. Baguhin ko class yung ano. Maybe ito. Let's go back here. Residuals. Baka ayaw niya yun. Okay. Residuals ng model 1. Alright, then run ko ulit. Oh. Dapat pwede ito eh. Q. Type is equal to Q. Okay, anyway, class, kung ayaw ni Q, no? We either use box peers or yung box test. I'll have to check no, kung bakit siya nag-ano. Just wait for me to post again kung ano yung problema dito. Okay, and lastly, class, so ano ibig sabihin nito? What does this mean, class? Almost time. It means, class, na hindi sufficient yung ano natin. Hindi sufficient yung model natin na ARIMA. Okay, either we change that model, yung ARMA 004, pero yun na yung best model natin, di ba? Based on the auto.arima test, auto.arima function, that's already the best model. Okay, so what happens pag ganun, class? Pag ganun, it's indicative that, okay, so last ko na, ano to, class? Ito. Control C. Chat. Control V. Alright, chat ko rin dito. Ano ko dito? Control V. Alright. So one way, class, is to test. Kasi yung plinat natin, class, tingnan natin ulit ha. Let me plot again paki-install, class, yung North test ha. While I'm plotting, plot yung mod 1 residuals. Okay. Diba, no? Stationary siya, pero may mga volatilities dito, no? May mga portions na hindi constant yung variance. In fact, class, if we do the ACF of yung, sige, model 1 residuals. Sama na natin PACF. If we plot this, tingnan nyo, class, no? May mga significant spikes dito. There. You can see with the PACF, there are still significant spikes. Hindi siya white noise eh. Okay, yung ACF, class, mukhang white noise. Although parang may mga small at long lags. Pero dito sa PACF, class, no? May mga significant spikes at longer lags. Okay, so enter itong North test kasi pwede nating kunin yung I'll end in this class. I'm sorry for a little bit of extension. Okay. Okay, hindi ko nasulat dito yung arch test. Okay. I-question natin, class, yung arch test. FINLYTS naman to. No? All right. So this one, class, it will test whether may heteroscedasticity yung residuals natin. Okay? Whether may ano yung ano natin, class, may heteroscedasticity. Okay, and okay, so ito lang gamitin natin class para ano. Marami kasing arch test, no? There are plenty of arch tests. Okay, last na to class, sorry let me see kung isa, dalawa. Itong arch.test. Hinahanap ko yung sa North test. Ayan, ito pala class, ito. Para sa akin kasi mas madali ito. No? Alright, so we're using the North test package. Okay. So ang function niya, class ito lang, arch test. No? Mas simple siya. Okay, so let me go here. Last one class. So library North test, and then check na natin class yung arch.test ni receive. Yan. Receive class. That's our object, di ba, ng residuals? All right. So what does this tell us, class? What does this tell us? Ang null hypothesis nito is that your residuals are homoscedastic. The p-value is very much low, very much less than 0.05. Therefore, we reject the null hypothesis that the residuals are homoscedastic. Okay? Ang alternative niya, heteroscedastic ng residuals. So pag ganyan, class, hindi sufficient yung model natin. Ibig sabihin yan, heteroscedastic residuals natin, either baguhin, mag-transform pa, or the way to go now is to do GARCH. Okay? So up to here, class, yung exams natin, ano? Up to that point where you will have to test the residuals using Leung box, using box pairs, using Q. Siguro ino-notes ko na lang, class, kung ano nagkamali sa Q, and also the arch test. But of course, class, pag yung Leung box and the box pairs test tells us that there's no correlation, no autocorrelation among the residuals, okay na yun. No need to go to the arch.test. Okay? So, but of course, you can still test that, yung arch.test. Okay, so let me stop recording now.